Howdy. This video is a little bit different than my normal ones, but I get asked quite often about soldering, so I figured it was about time to do a brief video on the basics. And to get started, you just need a few things. Obviously, you need a soldering iron, and you're going to need some soldering flux, and you're going to need some soldering wick or braid. Um, what I use MG Chemical Super Wick. It's the only wick that I can use these days. Ever since I started using it, it works miles above everything else. I'm not sponsored or anything. This is just what I use. Then there's this is Amtech's solder flux paste, and I use that quite a bit. It's very good. And I also use Kester's liquid flux. This is Kester 951. This is a rosin-free flux. It's extremely clean. It's meant for like manufacturing, like wave soldering processes and stuff. But I like to use it when I want to keep the area I'm working on pretty clean. Because rosin fluxes, see, this is a Kester rosin flux. This is a 1544, or I think most commonly people just label it 154. But this one and the Amtech both, they get very sticky and tacky because it's made out of rosin and tree sap. So they leave a lot of gunk that you have to clean up. So if you're working in a really tight spot, I really like to use this one. That's about it. I also recommend that you have a hot air station. I have a few here off camera. I have a Quick and a Metcal one, but hot air is hot air. You don't really need too much too fancy. As far as the soldering iron goes, I have a pretty expensive heavy duty one. Not most people will need this. Now, if you are in the market for a top of the line soldering iron, you don't get any better than Metcal. It's definitely a beautiful unit, and if you solder every day, I'd say you need this one. But for most people watching this video, you do not need something so heavy duty. And thankfully, I was recently sent a soldering iron from KaiWeeTs, I think is the name. If I'm getting that wrong, I'm very sorry. Now, I haven't opened it yet. I think everything is probably ready to go right out of the package. So let's get into it here. There we go. This is the KETS02. Now, they sent this to me for me to, try it out and tell people what I think about it. So I will try to be as honest as I can. But let's see what we have in here. So here's the instruction manual. Don't really need that. There is the power supply there. That is extremely heavy. That's pretty heavy duty. I like that actually. Here is a tip. I hope it's got more than one. That's not my tip preference here, the style. Can't remember what that's called. It's kind of like a chisel, but it's a lot fatter than a chisel. And here is the unit itself. It's a very nice little unit, that's for sure. Feels nice holding it. Twist. I wonder if that's how you put the tip in. Does that sit? I guess so. Oh yeah, so it sits there like that, and you push it in, and then you screw it down. Oh, that's pretty nice. I don't suppose you could really do no hot swaps, so that'd be kind of hard. Let me see. So since this has the grips on it, you really want to position your tip how you want to be able to use it. So, well, let me set that down for now. Let's see what else is in the box. So this is a cap for it. Does it fit with the tip on? It does. That's nice. I think this is metal too, or aluminum. That's actually pretty nice. Looks like more stuff down here. Again, I hope they got some more tips. Now, I haven't done any research on this thing, so you're gonna have to bear with me about trying to figure it out. That's a tiny little holder there. I don't know about that, but that's okay. Let's get him to the side. And we do got some more tips here, thankfully. So it's got two knife tips, which is nice. I really enjoy knife tips. And then two conical tips. I don't care much for conical tips, but they're not bad. And another hoof-looking thing. I forget what these are called. It says BC3 soldering tip, a KETS01. So I really like knife tips, but I think for this video I will not use that. I think I'm going to use the most common tip, maybe that conical one there. Let me see what this one is. So this tip is pretty good. Let me see if I can get it on the camera. So I'll probably just use this one. Let me set these away. Maybe try a few. So this is the cable. Nice leather. Oh man, that feels really nice. I'm actually really surprised. You know, a lot of times companies will like to send, you know, us stuff to review and look at it. I tell you, a lot of times it's not very good, the quality of them, you know, the freebie stuff that they send, but this is actually really nice. All right, so we got this guy plugged in here. Let's see what we can do. So I think I just turned it on. Uh, when you first turn an iron on with a new tip, you definitely want to tin the tip quick. You want to turn it on and put some solder on there. So I will be using lead-free solder in this video. It's Rel 22 by I think it's AIM. Yeah, AIM. American something mechanics or something like that. Or no, I'm sorry. It's something metals. But there, yeah, okay, so now it's going. Okay, so it's set at 300C, which I think is too low. I'm going to go to 350. Now, I bet you there's all kind of menu things that you can set. I'm not going to get into all that right now. Maybe later, at the end of the video, I can go through the manual and look at some of that. But right now, I'm mostly interested in the function of the iron and teaching you guys some basic soldering. So a couple other things I forgot to mention that you need is obviously, you know, solder. And like I said, I'm going to be using uh, Rel 22, which is a really nice solder for automotive stuff. It's lead free. It's designed to, you know, not crack as bad. It's got some special stuff in there to keep it from cracking, kind of help prevent against cold joints and stuff like that. It's pretty top of the line solder. I definitely enjoy it. It's doesn't get shiny like if you use lead. I'm not gonna get in an argument about lead free versus lead. They're both work just fine. That's not an excuse, you know, that you gotta turn your iron up a little bit. But if you want to use lead, go ahead. Just keep in mind that automotive modules are all lead free since a long time. So even though you'll be using lead, you still have to work with lead free and you'll be mixing alloys, you know, by using, you know, leaded solder inside of the module. But another thing that you need is you can use this little sponge here, or you can get these little brass balls. I usually use the little brass balls, and they're just to clean your iron tip. And cleaning your iron tip is extremely important. So after any job where you're soldering, you make a few connections, you make a few joints, you have to clean your tip. If you don't, you're gonna start burning the tip up. It's gonna start oxidizing and it's not gonna work. You'll see people struggling to solder. They have a soldering iron and the tip is all brown and there's only one little tiny spot on there that holds solder. Now, if you look at my tips, they're gonna stay just like this, just covered in solder. Because after each use, I clean the tip. And if it's sitting, I'm kind of spoiled about my Met cow because my Met cow just automatically cuts off. But when you have a hot iron sitting, you want to just leave the tip wet. So I'm soldering, I'm done. I set it down. I'm going to leave it. Don't do that. That's bad. Instead, you solder, you clean, you wet, and then you set. Okay? That is the best practice to keep good tips. But since they sent me this set, I'm going to use their little thing. You're supposed to use water in here. Okay, so this sponge is extremely disappointing. They should fluff all the way up. Well, it's fluffed up a little bit, but it's still not very much. But we are going to use it. And now, when you use a sponge, you just want it wet and damp. You don't want it like soaking full of water. You want it damp. And then you're going to clean your tip like this. Now, whichever method you prefer is fine. They both work, the sponge or the brass ball. Just if you use the balls, you have to make sure that you get um, the softer metal because some of the really cheap ones will use a really hard metal and then they'll just coat it. But what ends up happening is the coating starts coming off and then you have a really hard metal that actually scratches away your tip and they'll ruin your tip. So do not buy the cheap ones. Make sure you find good ones. If a magnet, sticks to that ball, then don't use it. That's how I always do. But let's set this down. I guess that's how that works. It works, so you can't complain. All right, so let's finally do some soldering. Let's go ahead and get this D sub onto this PCB. Now, this D sub has what's called solder cups on the back. These are meant to, put wire into it and then solder the wire. But in this case, I actually have made a edge mount here on my PCB where we can slide it between them and solder to the PCB directly. There's no wire needed. Now, for good soldering, you need a few things. You need a clean surface that's free of oxidation. You will need flux and, the soldering iron's heat. And you need a good, even heat transfer to uh, weld the two pieces together, basically. Without that, you will not have a good solder joint. Now, I'm going to go ahead and use the Kester 1544 liquid flux for this. Okay. And I'm just going to put it on there very liberally. You do not have to be worried about using too much flux. It's rarely ever too much flux. Okay, so I have the KETS02 powered up. I'm going to turn it on. I'm going to go ahead and clean my tip before I get started. If you remember, I mentioned earlier, always keep your tip clean and keep it wetted with solder. Okay, the solder I'm using is Rel 22. Okay, so now let's go make our first joint. And what you want to focus on is to make sure that your getting heat to both parts of the component. So we have the PCB, okay? We have the pad that we're soldering to, and the solder cup in this example. And here you see the solder mask. You see I can't place solder to this. See that? The solder will not go onto that. That's why it's called a solder mask. It prevents it. Okay. So I'm just getting used to this hoof tiff here. But like I said, you want to try to heat up both the solder cup and the pad at the same time, and then we're going to feed in the solder. Okay. And if you noticed, the solder wasn't flowing perfectly, so I spread my heat out a little bit more so that it would flow to that area. So like if I just feed the solder here, in that case, that time it actually worked okay. But if we were to come in and not apply enough heat, then you'll see it kind of clumpy, and you see it's not really flowing well. You want to make sure you try to get an even heat through both of the devices there that you're welding together. Okay. Don't worry too much about, too much solder. Too much is usually better than too little. And if you put too much, then you always have the solder wick. See, let's give you an example of too much here. That one's actually okay, but let's just go crazy here. Okay, now that just it functions, and it would work, but it's rather ugly. So we're going to take our solder wick, which is basically braided up copper. You see the little copper there? That's just what it is. And we're going to place that. We're going to start heating it. And this will just suck up or wick up the solder. Okay, and you can wick it all up if you wanted to. See, I wicked up too much of it. I could have stopped, but I wanted to demonstrate for you. So now I got to put a little bit back. Okay, and that's good. So we're just going to keep going here. All of these are going to be pretty easy, pretty straightforward. The key is just to make sure that you're heating everything evenly. And you have a good temperature. I'm set at 350. You can actually turn it up a little bit, but this is doing okay. You want to apply the heat quick. You don't want to be here hanging around. So you wouldn't want to set it at like 300 and then have to hold it twice as long. That's not good. You want to get it soldered quickly. You want to apply the heat, apply the solder, and it be done. The pads that we're soldering to, they're held on by adhesive, and the adhesive has I guess a melting temperature, and it has a temperature that's pretty high, but it's for a short period of time. So if you're heating it for a long period of time, you're going to be hitting that limit and going over it, and then the pad comes off. It will you know, just start sliding around. Okay, so for this example, I'm not going to put any flux there. Now, my solder itself does have flux in it. It's a flux core, but typically it's not enough still. So let's go ahead and see what happens when we try to solder without flux. So I'm using very good solder, and it actually turned out okay. Okay, that one is good too. It's going to be hard to demonstrate a bad joint But let me try it like this. So let me wet my tip here. Okay, and this way all the flux burns off. And now you'll see that it doesn't work as good. See, the joint was slow. You see how it's got like it kind of formed itself funny. It kind of pulled away with the soldering iron. See, I'll show you again. That actually worked too. You see how it's got like that little ridge? And look, you see it's like, man, the solder won't stick. What do I do? This is the result of no flux. So this side, I'm going to use this liquid Kester flux, the 951, the really clean one. This is the rosin-free. It's not quite as aggressive as a rosin flux, but it's really good at just keeping things clean. Okay, so that is good. Just kind of clean up this mess that I made here. Okay. I'm gonna go ahead and finish this up and then we can move on. That was an example of SMD soldering basically. That's basically the same principle. This next part that we have to do is these little headers here. And this is going to be an example of through-hole soldering. Now, I'm not using a vise, so I'm going to try to hold this in my hand. And I have to hold it a special way to make sure that it stays straight. Okay. And for whatever reason, this is a little bit more difficult to solder usually because this header is held in alignment by these really cheap plastic guides, I guess you would call them. And if you hold the iron there for any extended amount of time, it actually will melt them. Okay, so I'm going to put plenty of flux here. I'm going to clean my tip, and since I have only one hand, I cannot feed the solder while I'm holding it, so I'm going to wet my tip, and then I'm going to come and just do what's called like tacking it down. I'm just going to kind of hit two of the corners, opposing corners, just to kind of lock it in place. Neither one of those joints are good, but that's okay because their purpose is just to hold the connector in its place. Okay, and then I'm going to come back and feed each joint like you're supposed to. Okay, and you'll see that makes a much better joint. So you can solder by, wetting the tip first, but truthfully, you should heat both things and then apply the solder. You shouldn't, try to apply the hot solder from the tip. And part of that is because the solder is designed, with the flux in the center, kind of from the example I gave earlier, but there's more to it than that. It's part of it is, the two surfaces being hot and ready to kind of weld together there. Okay, so we have all that. We just have these two bad joints left over. So we're just going to redo them. See that? You don't have to be worried about a bad joint because you can just always apply flux if you need to, and then you can just always reheat it. Okay, and you see I clean the tip again, gonna wet it. Okay, and then we're gonna set it back down. And we're gonna use our little holder there. I had been using my Metcal one there, and it fits in there good too. Alright, so this next thing I'm going to solder is going to be this little relay here. We have 4 through-hole components that I'm going to solder. I have an SMD resistor we're going to put on, and then I have a little MOSFET that's going to go here, but we're going to use hot air for that. Okay, so I'm going to use some of this Salter flux paste. I always try to say solder paste. It's just flux paste. But we're just going to put some of that. Okay, gonna clean my tip because if you remember when I put the tip away, I had wetted it, and that solder, it sits and it starts oxidizing on the tip. So we don't want to use that. We want to wipe it away, but you do want that solder there so it goes bad rather than your tip just sitting there getting hot. But anyway, we have that cleaned away, and now we have our flux paste here, and I melt it down a little bit just so I can see. And now we're going to go ahead and apply our solder. And if you can see, this has a pretty big hole, but that's okay. We will fill that hole up, no problem. Okay, and this is a little bit harder to get it heated well evenly, but there we go. You see that is a very nice joint there. We're going to do it again right here. Okay. I was able to use more of the tip on this one. That's why it flowed so much more evenly. Like if I'm down here just trying to heat from there, it's not going to work good. I want to use the size of this tip to really transfer the heat. You know, soldering is a lot about just transferring heat. Uh, Things like this, um, you know, they're made with copper underneath the solder mask. A lot of it is copper, and copper itself will transfer heat away from what you're soldering. So you need to make sure that you're applying more heat than what's getting transferred away. And sometimes there comes a point to where your soldering iron cannot keep up with the heat, you know, dissipation, and you will not be able to get the solder to melt. And in those cases, you can use something like a preheater to heat it up. You can use hot air, you know, and your iron. And the hot air then is the same thing as a preheater. Or maybe you need a bigger tip. Like if you have too small of a tip, you'll get that same thing. Okay, so let's try this little SMD resistor here. Since I don't have 3 arms, what I'm going to do is I'm going to wet my tip, even though I said, you know, that's not the best thing to do. Sometimes that's just what you got to do. Okay, and then I'm going to hold it in place. And then I'm going to come and just do like that. A little bit shaky. See, I don't need to make it perfect, but I can't help it. Okay, so that side is done, then we can let go and come over here and feed onto this side. And then if you're not happy with that, then you know, you can always touch up with hot air if you want. Okay, I'm going to touch that side up again because I did not feel like it made a, you know, good joint. Now I have a tiny little MOSFET that we need to put on this spot right here. And, you know, I won't be able to do this with the iron, but I do want to do what's called tin this area. So I'm going to tin it. That just means I'm going to apply solder to it. Okay, just like that. Now I am going to apply more flux. That's right, more flux. You do not need to be shy about using flux. And I'm going to get my little MOSFET here, if I can pick it up. Okay, it goes this way. I'm going to rub him around in that flux because I want his pads to get nice and fluxed up. And now I'm going to use my hot air here. I'm working under the microscope in the camera, so, you know, I'm trying to show it. Normally I would be right on top of it like that. I'm going to come in from the side a little bit. But typically when you come from the top, it will actually pull itself, once the solder liquefies, it will usually pull itself into position as long as you have it somewhat close. See, like that's pretty close, and hopefully it will stay in that right position now. So I just saw the solder liquefy there on that one side. Yeah, there it goes. You see it kind of wiggling? That's good. I'm gonna do this guy too, because I don't like the way he's a little bit one-sided there. Okay, that's good. So now I'm gonna let that cool down. So if you are already a soldering guy, you're gonna look at this joint right here and you're gonna say, man, that joint is super dull and really weird looking. And you're right, that doesn't look like a typical solder joint, but this is the type of solder that I'm using. It's Rail 22, and it has specialized grain stuff in there that kind of is supposed to help it from whiskering and cracking. Um, it was some kind of solder that's specially made for automotive stuff, so I like to use it. But it does look a lot different than your typical lead solder joint. Your lead solder joints are really shiny when they're good, and they're kind of dull when they're bad. So this would look like a bad joint if that was lead solder, but this is not. This is what this solder looks like. So that's good. And we can test its function if you want. I should hit this button and we should see that light up. There it goes. And my thing is a little loose. Okay, there we go. I take it out. We don't see it. Let's try it again. Good. Okay, so I have several more of those to make, but I will not bore you with that. I'll try to find something else to solder. Another basic soldering pitfall you might run into is something that has a large thermal mass. And now this is a bit of an extreme example, but what we have here is a flex PCB. This is not the standard fiberglass one, it's just a flex PCB and it's glued directly to an aluminum case. This whole thing is aluminum. And on top of that, the component that we need to remove, which is this diode right here, is soldered to a massive ground plane, which is a very large piece of copper, and also the cathode is soldered to a large plane as well. So this takes a lot of heat. Now, I'm definitely going to change tips. I'm going to switch to this bigger knife tip here. The knife tip is nice for this because it can fit, you know, it can fit like that. It can really get in that corner and heat it pretty well. So let's swap these tips. I do not expect that this can do it itself. This should not be able to remove this by itself. Now, my Metcal, I can do it with certain tips, not counting this side, just, heating the ground side. But what I usually will do is I'll wet all of it. I'll put fresh solder here and here, and then I will use hot air, and then I'll also apply some soldering here. But a lot of people will say, oh, use low melt solder or use lead solder. Yeah, you can do that. It will help a little bit. It's still not enough to remove this with just an iron, safely. You're going to end up messing stuff up. But anyway, I am going to turn this up. So right now it's set to 350. I'm going to turn it up to, I want to actually wet the tip. Remember I told you whenever you use a new tip, you should always wet it. Okay, let's go ahead and do that first. And I want to turn this up. Why is it not turning up? Why is it not letting me turn it up? Okay, there we go. I'm going to turn, this goes to a max to 420, but let's not do max. Let's just do 400. Okay, and then I'm going to take some Kester 154. I'm going to put it here and right here and put some on this side. And I'm going to put fresh solder here. And I'm still just going to use my regular lead-free. Lead would make it a lower melting temperature, but I'm, trying to tell people it's not a huge deal. You just use a little bit hotter heat. Now this guy is doing okay for this. This is a 65-watt iron, I believe. So I'm going to put this here. I'm going to turn my hot air up a little bit to 420. And then I'm going to start heating. I'm going to wait a little bit before I put this back. I don't want to damage the tip or anything. Go ahead and heat this up for a little while. So this iron has a power meter on there. Haven't really paid much attention to it. It's saying it's at 40% power. And it's melting. It is melted now, so that's fine. I'm going to heat this up a little bit, get that just hot, and then we're going to come here. And it's off. So that did take care of that with the hot air, which is the same way that I remove it with my Metcal. As you can see, I used it, I cleaned it. Now you want to wet it. Okay. Always stick to that. Let's put some flux here. And now is another time that we will use the solder wick. When we want to put this replacement part here, you don't want to use this dirty, rough, surface solder. You want to clean it all up. Okay. You can do this, but you still have kind of the old solder there. So it's best just to take some solder wick, if I can find it. There it is. And just clean all this off. Let's see how this guy does at cleaning these, because these are very big copper areas here. I'm trying to watch the power meter too. Kind of hard to see the way I had the tip in there. You really got to pay attention to which way you put the tip in if you want to pay attention to the meter and all that. It's doing it just fine. Wow, I'm actually surprised at that. It did a good job. So it does have good power. So right now I'm still at 400C, which is fine because we want to put a replacement part on here. And I will use hot air again when I do this. But what I like to do is get this side first. Okay. So I want to heat up both parts. Remember, we want to heat up not only the pad, but also the pin that's being soldered, or the part that's being bonded, welded, however you want to say it. Now, right now, it's kind of failing to heat this up. There it goes. I just had to make sure I got the tip on that right. It's still not, um, it's still not the way it's supposed to be. Like, it didn't really flow well. So it's kind of awkward looking. So I'm gonna try to fix that with hot air. But what I want to do is I want to wet my tip, which helps just globbing the solder like this. It helps, the heat transfer from the iron to where we want it to go. I'm gonna put even more. Now we're gonna come back with the hot air. Okay. And the back part is done. The front part is not good yet. Okay, there that is. Okay. You see, clean it, you use it, you clean it, and you wet it. Very important. I guarantee you, if you do that, clean it and wet it after every time you use it. That will improve your soldering 100% because you always start with a nice tip. Another thing is flux. You have to use flux. There's so many times I see people post on forums, they post pictures, they say, "How am I soldering?" And it's all globbed and funky looking. It's because they didn't use any flux. Now, I know there's flux in the solder, but it's not enough unless you perfectly hit it right at the same time, you know, and you don't linger, you don't have to work that spot several times, then it sometimes is enough, but you're not doing yourself any favors by not using flux. So, all right, so moving on to another thing we run into. Um, this is a IC, a rather large one. It's a 64 leg MCU, and it's pretty common that you have to take these off. So what I'm going to do is use hot air to do this, and I like to apply paste around it or the liquid flux, whichever one. This is one I grabbed. Okay, the cleaner one probably would have been better, but then I'm just going to apply heat here, and I'm going to make circular motions around the legs. Now, if you have a specialized tip that's about the same size as the chip, you don't really have to do this circular motion, but I'm doing the circular motion because I want to try to heat all the legs up evenly. Okay, so I'm going to keep heating this up. And what's my heat set? My heat is set at 420C. Okay, I can see that the solder got liquid and then it come right off. So I'm going to set that there because I'm actually trying to do this as I'm working. I need to get some data off of that and then we'll come back. But I'm going to pause while I do what I have to do in the work that's not really related to this. And then I'm going to show you guys how you solder this chip back. So I've gotten everything done that I needed to do. And now it's time that we solder this back. Very important, since we're going to be using the soldering iron to put this back, we want to clean these pads very well. Let's see, oh, my iron fell asleep. And it woke back up. So I'm at 350C still. I'm going to clean my tip. Now I'm going to use this solder wick here. And I'm going to let it get hot first, the solder wick. And once the solder wick is hot, then I will carefully just go over top of all these pads. Now, you don't want it to be low temperature to do this because then your solder wick can actually, you know, get soldered to the pad and you'll rip them off. And you don't want it to be too hot because if it's too hot, you can easily remove the pads from the PCB, which we don't want to do. Okay, but that is all cleaned up. And now that that is cleaned up, I'm also gonna put some IPA here, get a little tissue, and I'm gonna wipe away all the old flux and everything that I had been cleaning. Okay, just like that. Get a brush. This just helps keep the area clean. When you're doing rework, especially automotive stuff, there's a lot of conformal coating, and it just kind of makes a mess when you're soldering. So you want to keep it clean as you can. And you definitely want to get rid of the old flux as well. So we're going to look at this under the scope, and it doesn't look super clean, but it should be enough. That rosin flux is a vicious thing. Okay, so it's clean enough for me. Now what I'm going to do is let's use our liquid flux for this. You can use the solder paste if you want, but the solder paste tends to block the, from being able to see the pins and the pads. So right now it's kind of sticky from where I did use the solder paste, which is a benefit. So right now, I have this stuck here and it's staying there. See, that's actually pretty nice. Usually you have to kind of hold it. Let me go ahead and drop some liquid flux here. Again, this is the KETS0154. And you don't need to worry about dropping too much. Like I said, it's not a big deal. Flux is your friend. You'd rather have too much than too little, and the majority of things that you're doing. Now, I didn't change the tip. I still have this nice knife tip, which is fine. And I want to show you that it's no big deal if you mess up. So right now, I'm gonna uh, just tack this down a little bit so it doesn't move. See, I just moved it a little bit. I don't want to do that. So I'm going to put a little pressure. I want to hold it. Okay. And I'm just going to put some solder there. Now I'm going to show you a drag technique. Works very well with this knife tip, and it works very well on stuff like this. Let me clean the tip, and I want to get just a little bit of solder. I'm going to hold this down still. And to drag, you just come and just drag across. Okay. Now I'm going to swipe down. I probably could have had a little bit more solder. So I'm just going to kind of come back and drag a little bit more. Now I want to show you how nice this looks before we move on. Okay. So we're going to see that every pin, let me try to focus a little better. We're going to see that every pin is soldered. There's no bridging, there's no excess solder. So this guy is a little bit light on the solder, so I'm going to add just a hair more. This guy too, I'm just going to add just a hair more. Don't think I needed to, but I'm a little bit picky. Okay, so that's one way to solder a chip that's like this with a lot of legs. You can also come and just do one by one, but I'm going to show you it's no real big deal anyway to do any kind of way. So, well, look at this mess, right? It's like, Jesus, what did you do? It's not really a big deal. Let's put some more flux on there. And what we do in situations like this, we're just going to add flux. We're going to come to the start. Okay, and look at that. See how I swiped it down and I took some away? There's still a lot there. That's okay. So we can also just carry it down. You see how I'm carrying it? Now, if we look back here, you'll see there's no bridging. There's no big globs anymore. It looks good. It looks like it's, how it's supposed to look. We just have this big glob here. Now we can heat it up and try to steal some like this, which I did. I stole a big glob. And if we keep doing that, you can actually take it all away. See this? Now, this is just one way to do it. Okay, another way is to, and the more stable way is to actually have a big glob there and then to come back. So like, we pulled all this glob here and then we just come here with some wick and just suck it up. And that's usually the way that you do it. You don't usually just swipe it away when it's that much. If it's a small amount like that, then that's when you generally swipe it away. Okay, so don't be worried if you glob solder. Now, without flux, that wouldn't have been possible. Without flux, the solder will not flow. It won't be, like have that nice clean liquid reaction that's sticking to your iron and following where your iron is heating those spots. It won't do that. It will stay where it's at, or it won't want to move. You cannot manipulate it the same way. So you have to use flux. Okay. Now another way that you can do these, if you don't like to, drag solder, or you're still too worried, you can still go pin by pin. So like you can come here. I'm gonna keep using this big tip. I'm very used to a knife tip. Um, it's kind of very familiar to me where I used it quite often. But if you have a regular conical tip, you can do the same thing. You just come here. That's not working too much. And you notice the solder, it doesn't seem like it's sticking right. There, I finally got it to go. So you know what I'm going to do? I'm going to add more flux. Because whenever solder is not doing what I like it to do, it's a good idea to add more flux. Now this knife tip is not really made for this, so it's a little bit more difficult, but we'll try to do pin by pin. Okay, and this is doable, and like sometimes I'll do certain things like this. Some chips, the legs are a little bit more fragile than others. This one actually is pretty sturdy. This one is a lot easier to solder than some others. But you can do it this way too. Okay, so that's good. Now we have one side left, and let's just get this done. Okay, I'm just gonna glob solder on there and drag. See, there's nothing to be afraid of. It's done. Perfect. I'm only doing this just to even out the solder, make sure it's even. The first drag, everything was complete. So now I'm gonna go ahead and clean this off, and we're gonna look at it under the scope. This, I just use IPA and a brush. My kids' old toothbrushes usually work the best. And you'll see this rosin flux. It's not so easy to get up, but it works the best. It definitely is the most aggressive. And if you're new to soldering, you definitely want to use a good solid flux. What happened here? Something's not right here. This has a broken pad or something. It does. I have to turn my light on a little bit. I can't see in my microscope that well. So I'm not sure what happened here. Is this a no connect pin? This is a no connect pin. Or either it has a via behind it. So I'm just gonna ignore this. This is actually fine. I'm gonna cut off this excess here so that it doesn't pop around and bridge. But let's go ahead and inspect everything while we're here and zoomed in. Okay, everything looks good so far. This I don't like. You see this? I think this is the side I probably did pin by pin. That's the wrong iron. So I'm gonna redo that spot because I don't like it. Okay. As long as you have flux here like this, and this is even after I cleaned it, you see it's very easy to rework. Okay, they're all good. Let's check here. These look really nice. These all look perfect. This is one that I've probably did the dragging and the swiping. These ones also look perfect. Still just a bit of flux. I'll have to clean it a little bit better. This side, they look good, but it looks like the pins were higher than they were supposed to. which happens sometimes from just legs being bent, or when you take it off, sometimes if you lift it that way, you'll make these pins a little bit higher. I just want to touch up all of these to make sure they're good. Okay, I think everything is good. That probably wasn't necessary, but just to be sure. Okay, so that, I mean, that's basically it. The only other really thing that is pretty basic in soldering is when you're soldering wires to vias for like reading ECUs and stuff like that in boot mode, or I guess any other kind of repair if you need to, do BDM or JTAG or something like that. And it's very simple. So you'll find some vias on your boards. I'm just gonna put a little flux here. So you'll have a pin out where you're supposed to connect wires so that you can, hook up your reader, and you'll see, vias or test points like this. So let's say I need to connect wires to these three test points. Well, you know what? Let me add one to this capacitor. I'm going to add a wire to this test point, and to this test point. Okay. So what I do is I flux it. Well, first I clean it if it has conformal coating. I clean that away first. I've already done that on that. Then I flux it, okay, and then I'll add solder to it. Okay, I'll add my own solder to it. Let me get a better angle there. Those are my 3 points, and I'm going to add a jumper wire too. And then I come in with my wire, and I have other videos about this, but basically I'll put more flux down if I have to, or I'll just rub my wire through some flux. I'll take some solder on the tip of my iron like this. Okay. And then we're just gonna hold this to it. Okay, and then you just heat it until it sticks. And this one is not such a big deal to make it look pretty because we're gonna take it right back up. So now we have this one, and we're just gonna do it again. And we have one more. Okay, I'm gonna heat it up. This one is a lot smaller, so you have to make sure you get a good connection, and that's not a good connection. It looks like it, but look, if I do this, now look at the crack. That was a cold joint, and that is because my wire tip did not heat up enough to let the solder, kind of bond with it. See, there it goes again, because I'm pulling it away before it cools down. Now this one is better. Um, the only problem with stuff like this, and when you're doing these wires like this, is it's very easy to rip the test points off or rip the vias up because this wire has a lot of stress on it. So you really want to make sure you put your wires in your machine and you're gentle when you have them like this so that you don't damage anything. Now this, I don't actually have to read anything, so I want to take these off. Okay, that is it. Just remember to flux it, add some solder to it, and then your wire will stick very easily. And, soldering itself, to me, I think it's a very basic thing. And once you get it down, um, it's not hard to be good at it. The main thing is just remember that flux is your friend. And also good tips. Good tip care is one of the most important things that you can do because I think it's the most common thing I see where beginners are actually failing. And if you don't have a good tip, you can't transfer the heat. So keep your tip clean, use a lot of flux, and you're good. Uh, Lastly, I wanted to thank KaiWeeTs for sending me this iron. It actually turned out to be pretty decent. I'm a bit surprised. Out of all the swag I've gotten, this is definitely my favorite, and I don't feel I really did it justice by talking about it, because there's so many different functions that you can perform through the menu. It's only got these two buttons, but with those two buttons, you can do a lot of different things. Like you can change the brightness of the screen. You can set standby modes, like where this says one key standby. You can recalibrate the temperature if you need, which I didn't even check the temperature. Let's see how well the temperature holds up. So this is 350 is what I have this at. Let's see how well it works. So it overshot it a little bit, but I have a pretty big tip here. No, it's right there now. I don't know if you can see it good. So 350, that's pretty good. That's not too bad. A little bit of overshoot, but that's not bad at all. And it has where you can calibrate that if you wanted to get it dead on. Personally, me, I wouldn't worry about it. It's also you can change different sleep times. If you don't mess with it for a while, it goes to sleep. So you can change the temperature for when it's sleeping. Let me just see what other functions it has here. Let's see, it's got a child lock mode. Also you can switch the display. If you're like left-handed and you're holding it here, you can make the display flip so that it wouldn't show upside down. See, like right now it's upside down. If I turn it on left-handed mode, then it will flip it around. I'm not a lefty, but I'm sure they appreciate that. So there's some maintenance stuff and then just different languages. Man, they got a lot of different languages in here. So this is a 65 watt. I don't know how well my camera is picking this up. It looks kind of fuzzy, but it's a 65 watt. It says the operating voltage. It can be from 9 to 20. So whatever your power supply is, you're not going to be able to use a 5-volt power supply like your phone charger to power this. You do have to have at least a 9-volt charger. And I think that's about it. So when it's at 20 volts, it's pulling 3.25 amps and you're getting 65 watts of power. So that's pretty decent. That's the max. And since I was using their power block, we'll go ahead and unplug it. Since I was using their power block, I was pretty much using 20 volts the whole time, which I was getting the full power, the full 65 watts. I see here that if you try to go down to 9 volt, use a 9-volt supply, your current is going to drop to 1.5 amps, and your power goes down pretty bad. It goes down to 13.5 watts. So really, I don't think you'd want to try to solder at 9 volts, even though it could. Maybe you could get by, 10 in some wires or something like that. I don't know. 12 volt is a little bit better. 12 volt is 24 watt. Still a little low. 15 volts is more doable. Almost 40 watts there. But 20 volt is pretty decent. It's decent, and I'm surprised. So yeah, it's I can honestly say it's nice. I haven't tried a lot of the newer irons ever since I got my Metcal. I stopped buying irons, but I know there's a lot of them on the market these days. But this is not a bad one. I'm not sure what the price is. I haven't looked up anything. I would assume it's probably you know under 100. but it's not bad. The only thing that it lacks is, a battery power. I know there's a few similar styled ones that are maybe battery powered, but after looking at, the power, I'm not sure how well the battery power ones would actually function. I don't think you could do this quality of work that I was doing with the battery for sure, especially things with higher thermal. So you'd want to use a cable anyway. Um, but yeah, it's definitely not a bad iron. So KaiWeeTs, thank you. I appreciate it. I will definitely use it. And thanks for watching, guys. It's kind of long. I hope you enjoyed it.